So in terms of my background, I have a bachelor's degree in geography and a master's degree in watershed science from Utah State. My focus at Utah State was fluvial geomorphology, and if anyone here doesn't know what that is, it's just a long mouthful of a word that means I study landforms that are shaped by running water, rivers and streams, primarily in my case, and Dr. Walter also does a lot of work in that field. My thesis work kind of focused on geomorphic and hydrologic effects of some dam and water diversion systems on a couple of streams in the Uinta Mountains. I worked with Jack Schmidt, if anyone's heard of him, as a professor up at Utah State. So that's kind of my academic background. In terms of work experience, it took about 5 years between undergraduate and grad school. I did a set of internships with the National Park Service, also worked for National Wildlife Federation, a nonprofit environmental group in Washington, D.C. I spent some time working as an environmental specialist for the state of Maryland. They have a small creeks and estuaries restoration program that I was involved with. Then I did a little bit of environmental consulting before heading off to grad school, doing some rapid stream assessments in Montgomery County, Maryland, for a company called Biohabitats. I guess I have an affinity for the bio something named consulting firms. And then since I finished up grad school in 2000, I've been working for Biowest.
Melissa?
Yeah.
I'll kick off the invitation era.
Yeah, please.
The internship with the Park Service, was that through the GeoCorps program?
No, both. I did 2 Student Conservation Association internships, one in Big Bend National Park, and then I worked for the Rivers, Trails, and Conservation Assistance program in DC, both through SCA. Yeah, and so a little bit background about Biowest. We're a small, full-service environmental consulting firm, about 50 employees altogether. Our corporate office is in Logan, Utah, so most of those 50 people are based in Logan. We have branch offices in Salt Lake. That's where I work out of. We have 1 employee up in Missoula, Montana now. And we've had Austin and Houston, Texas offices for about 10 years now as well, all of which are smaller than the Logan office. So, full service environmental consulting, what does that actually mean? We have a number of different sections within our company. One deals with environmental analysis and permitting. That's where a lot of our environmental impact statement type work, NEPA type work happens. We have an environmental engineering section, which really focuses on hazardous waste assessment and cleanup, remediation type projects, some groundwater geology type work. We have landscape architects, planners, GIS staff, a pretty big portion of our company. And then we have the whole suite of ologists, as one of my coworkers likes to say. So everything from fisheries biologists, ecologists, wetland scientists, vegetation specialists, wildlife, and so forth. In terms of who hires us to work, the bulk of our company's client base is primarily government agencies, the various federal agencies, the Bureau of Reclamation, Corps of Engineers. Sort of on the federal level, sometimes it spans into a combination with state wildlife management agencies. We've done a lot of work for various endangered fish recovery programs. We have a lot of work for UDOT, Utah Department of Transportation, both in the planning and compliance elements. We've done projects for Division of Water Quality, the Division of Wildlife Resources at the state level. I've been involved kind of in conjunction with our Texas offices on some Texas Army National Guard projects. That's sort of Texas, state, federal. Texas thinks they're their own country, so it's hard to say. On some of their training bases, doing some assessments down there. We also have done a lot of projects for local government, Salt Lake County, Salt Lake City, Summit County, etc. And then a number of sort of what I'm calling quasi-government entities. Most of those have been water districts of some sort. We've also done a lot of work over the years for what I'm referring to in the simple name as the Mitigation Commission, which is an entity that was established as part of the Central Utah Project, which, if you're not aware, is a many billion-dollar federal water development project that has allowed Utah to sort of harvest its share of the Colorado River and pipe a lot of that water supply over to the Wasatch Front. And when that was established, went through Congress, they said, hey, this is probably going to screw some things up. Let's establish a mitigation commission that has a big pot of funding to do some mitigation, some restoration type projects to help compensate for some of those impacts associated with developing the supply of the Colorado River water. Down in Texas, there's a number of river authorities that we work for. Basically, any of these entities that deal with water supply, distribution, or reclamation, which is the new PC word for sewage treatment. But all those folks care about things that have to do with water quality, both if they have to clean it up to provide drinking water, or if they have to clean it up to discharge it back into the streams and meet environmental requirements and not violate water quality standards. So that's kind of the suite of government and government-like entities that we do a lot of work for. We also work for private industry, particularly in our Houston, Texas office. They've been doing a lot of kind of compliance and assessment work for pipeline projects, petroleum pipeline projects. We've done work for power companies. We also have done kind of some smaller scale work for commercial recreational developments where they need stormwater drainage designs, or they need help. They want to build something right where a stream channel is. How are they going to reroute that or modify it or meet mitigation requirements if there are impacts? And we don't have on staff any professional engineers. We're more of science, resource science company. And so a lot of the time we'll get hired by an engineering firm that doesn't have that same level of environmental expertise. And so we can team up with those guys. And so we do some sub-consulting to those types of firms. I wanted to spend the next couple slides kind of touching a little bit on why do we get hired? What is driving the need for environmental consulting to exist as a profession? And really at the end of the day, most of the work can be traced to some of our environmental regulations. Endangered Species Act, I kind of mentioned that we've done some work for recovery programs, dealing with hydrologic or geomorphic barriers to recovery, particularly for fish species, has been a lot of my personal involvement. And then other folks in our company, the wildlife folks, the vegetation specialists, spend time doing inventories of threatened and endangered species, impact assessments, clearances, making sure that an endangered plant population isn't right in the pathway of a proposed pipeline alignment, something like that. So all of that has to do with things that are required under ESA, Endangered Species Act. The other biggie is Clean Water Act. Various sections of the Clean Water Act drive the need for a lot of the work that we do. Section 404, the wetlands, no, you're not allowed to just dump fill in wetlands without going through a permitting and mitigation process. That's driven a lot of, in particular, kind of our stream restoration or floodplain restoration type projects often have been required by the Army Corps of Engineers under Section 404 as mitigation for impacts of some other type. The NPDES program of the Clean Water Act that addresses with point and non-point source pollution, that we've kind of done work under that, guys, in terms of doing stormwater management type work. One of the first projects I did when I started at Biowest was environmental inspections on the Snow Basin Road project just before the 2002 Olympics, which was kind of a controversial project. A lot of environmental attention and doing water quality sampling and being out on site as construction was happening to make sure that they weren't dumping a lot of mud in the creeks or impacting owl habitat if there was nesting, things like that. So inspections of projects that involve construction where there's the possibility of polluting waters if things aren't addressed properly. NEPA, I kind of mentioned NEPA already. I don't manage our NEPA projects typically, but I'll serve as kind of a water resource specialist. Federal actions requiring an assessment of what are the impacts to the environment associated with a federal action is really anything that gets federal funding. This needs to go through this process. And so from a water resource perspective, whenever there's a NEPA project, you end up spending some time gathering existing available information on hydrology, water quality, stream channel conditions, etc. And then trying to figure out, oh geez, well, if we change the way the flows are coming down this creek by changing the outlet to this reservoir, what is that going to mean for the hydrology? How is that going to change the sediment regime or the temperature of the water? How might that affect our fish or our riparian vegetation resources. So we look at those impacts and then also try to recommend and sometimes help the client design mitigation measures to address those impacts. And some of the most interesting work we can end up doing in cases is kind of the supplemental technical studies that often accompany an environmental assessment or EIS type project, where we don't really know enough about these existing conditions to come up and say what the potential impacts are going to be. If we don't really know what the water regime, what the flow regime is in a creek because it doesn't have a gauge, we might have to put a gauge out there and take a look at it over a period of a year or two to at least have some baseline data to start from. So we'll get into field data collection, monitoring, analysis, and sometimes model development to help us address impacts long term. There's also a number of state laws that sometimes drive some of the work we do. I'm going to, hopefully, depending on time, touch a little bit on Texas's Instream flow legislation. It's been interesting to be involved with some of our staff down in Texas who are primarily fisheries biologists and ecologists, but they've been doing a lot of work for various river authorities, and under some fairly recently passed state laws down there, they're really required to look more holistically at in-stream flow impacts. So they have to come up with recommendations for all types of flows, not just a minimum base flow that means fish can barely stay alive or something like that. They need to look at what flows do we need to make sure we don't lose our cottonwood trees, or what flows do we need to make sure that we still get sediment bar development, support the macroinvertebrates, etc. So that's been interesting to work on. And then also local ordinances sometimes drive some of our projects. Over the last 3 years or 4 years, I've spent a good chunk of my time working on some projects for Salt Lake City, who in 2008 passed a riparian corridor overlay zone ordinance that sort of guides development along the stream corridors within the city. It's a little late for that ordinance because most of the properties are already built up along the creeks, but not everywhere. And so they really needed some help figuring out what do they have, what resources exist along these creeks, and where there may be opportunities to implement some improvement projects. So that's all tied to some local ordinance development. So that kind of gets at the legislation. Sometimes our projects are driven just by infrastructure development concerns. Maybe a river is being uncooperative. I kind of have that uncooperative rivers parentheses in there, and that kind of makes me laugh because I kind of tend to think that people put themselves a little too close to rivers to have the rivers do their jobs, and so really we're the ones that aren't cooperating. But sometimes it doesn't work together. If you need to have a road or a highway, or you've built a home in a floodplain or near a floodplain, the river has decided it wants to meander or migrate towards that property, that poses a conflict, and that's where we sometimes get hired to come in and try to design some solutions to help stabilize the river, protect that property, or provide some recommendations on maybe you want to look at doing this a little differently so you don't end up in such a conflict long term with the river. And then mitigation and development impacts, things like that, where maybe just a new bridge or river crossing of some sort's going in. How do you design that bridge to accommodate the floodplain and the river, or rechannel, stabilize the banks, entering and leaving that crossing? So that's kind of the other reason we end up doing projects. Lastly, basic inventory and monitoring. Some agencies, Bureau of Reclamation, Corps of Engineers, they have had many, many years since the early 1900s of repeat river cross-section surveys on places like the Rio Grande and the Missouri River. And we've been involved with some of the surveys on the Rio Grande over the years. And that's interesting. It's just basic data collection. And they have long-term records of this. They can track the way the rivers have been grading or degrading or eroding on the banks, incising, that type of thing. And it's just a general management tool for them to help maintain the levee systems that they're in charge of, and the river system that they're in charge of. Riparian corridor assessment, I kind of mentioned the Salt Lake City project, where we spent some time just inventorying stream channel and vegetation conditions, mapping where storm drains are present, that type of thing. In these kind of projects, we end up sometimes more of our deliverable is, say, a GIS data set in addition to maybe a written report. And this gives the agency or the management entity, the government agency, a tool that they can refer to when things come up. They can check and say, oh, isn't there a storm drain there? Maybe we should retrofit that, or is there something that can be done to create a water quality treatment feature in association with it. Texas National Guard, we spent some time down there just mapping their stream channels. They didn't have a good inventory of the smaller first and second order stream channels on some of their National Guard camps, and that made it hard for them to know when they might need a wetland permit for a new tank facility or anything along those lines, or a new firing range. And so we spent some time just mapping streams. So this is kind of the more basic, less applied, just providing a good data set that agencies can kind of manage from. The three main categories, I'm not going to spend a lot of time on these slides because I'll kind of get into some details with project examples. Our Watershed Science section kind of specializes in stream channel and floodplain restoration or stabilization type projects. We also do projects dealing with water quality assessment and mitigation. And that involves everything from some sample collection out in the field, collecting bottles and samples of sediment and shipping them to laboratories where they can be analyzed for nutrients and metals. We don't tend to do most of that in-house. It usually has to go through kind of an EPA certified laboratory, but we'll help make sure it gets delivered and analyze the data once it comes back. And then lastly, we spend some time doing more general types of watershed, stream channel, or hydrologic investigations. And this gets at some of those more inventory and monitoring type projects that I mentioned. So I want to spend a little time telling you about some of our stream channel and floodplain restoration projects. And I'm going to start talking about this Hobble Creek project. And it's kind of the only one that I brought more kind of a series of slides, because I think it's a real interesting project. It's also just kind of down the hill from you guys near Springville on the shores of Utah Lake. It's an easy place to go visit if anyone's interested in going to look at the property. And basically, the Hobble Creek project is something that kind of came about as a need that was brought up by the June Sucker Recovery Program. And I want to just get a little show of hands. Who here has heard of the June Sucker? Almost everybody. All right, quick look. That's good. That makes me happy because it's just down the road. The June Sucker is a federally listed endangered fish species that is endemic to Utah Lake. Utah Lake's the only place it lives, and it was listed in the 80s, I believe. And since 1999, there's been a recovery program and plan in place. And one of the objectives of that program had to do with establishing an alternative spawning tributary for the June Sucker. And this fish, it lives most of its life in Utah Lake. And then in the spring, it goes up the tributaries to spawn, lay its eggs. The eggs hatch, the larvae drift back down. And then again, they rear in kind of the lakeshore interface area and then live to be adults in the lake. And until the Hobble Creek project was completed, they were really only regularly seeing successful spawning happening on the Provo River, which is the main tributary drainage to Utah Lake. But there was concern that in doing that, you somewhat literally, kind of all the eggs are in one basket. If something were to happen during the June spawning run on Provo River, tanker turns over on I-15, contaminates Provo River, taking a huge hit to the population. And so the idea is it's going to be important to spread out that population a little bit so that they're not all having to count on Provo River working every year. And so that's kind of how we got involved in this. It was one of the first projects I worked on for Biowest about 10 years ago. Another fisheries biologist and myself kind of were sent out to go inventory all the different tributaries that enter Utah Lake and try to look and see which ones look like you might be able to implement some restoration measures to reinstate those tributaries as possible spawning options for the June suckerfish. And in the course of doing that evaluation, Hobble Creek, along with 2 or 3 other creeks, kind of rose to the top as being most promising. And for various reasons, the program ended up focusing on that tributary. They were able to purchase this 21-acre parcel of land down here. This is the old Hobble Creek channel, so near the shores of Utah Lake. And so we went into some additional field work, developing some concepts of, geez, where could we route the river? What kind of work could be done? Yes?
That doesn't look like a natural channel.
No, it was not very natural. It was completely dredged and channelized and levied. And it kind of, they routed it along sort of a higher spit of land. And really, my guess from looking at historical imagery, they really wanted it to get out of the way so they could farm more land down there. And it actually broke out in the floods in the 80s, and it kind of dribbled out through this area, and then they put it back in the early 90s. And so it kind of wanted to be more south originally, but it's a pretty manipulated creek system in that lower stretch. And so we got into some concept development, and then the full-on construction design started in about 2007. We also did the NEPA work, the environmental assessment, the public involvement components of kind of laying the groundwork for the project to be built. And this just gives you an overall location. I think most of you know where it is. But again, we ended up with this 21-acre field that we were able to convert into a naturally functioning delta that connects the creek more functionally to Provo Bay. And again, the primary reason the project happened was to try to get this spawning run established. Another component, though, that kind of came out, and we were real fortunate to end up being able to have a partnership with Utah Transit Authority. At the time, 2007, we were working on this. UTA was just starting to build their Front Runner South, the commuter rail system that is almost ready to be ridden on, I think, within a couple months. And they were going to have some wetland impacts with building that rail line, and they needed a mitigation area. And so they were like, hey, this looks like a good place to do the mitigation. And we're like, that would be great. We don't have money to build this yet. And the June Sucker program was excited. And it worked out great. It got done a lot faster than it would have because UTA actually funded the construction of the project because the timing worked out well for their mitigation needs. So that became a second objective, major objective of the project since they were funding the construction. So yeah, as we were talking about, this was not a natural channel, this straightened alignment out here. And it was trapped between levees. It was extremely flat. It would clog up with debris. Really, the fish, this is where fish were noted as staging, trying to find a tributary to spawn in. And they couldn't even find their way in here because it was so clogged up with debris and trapped between levees. And so fish weren't even getting in the river to try to spawn. And even if they had been able to, the larvae wouldn't have been able to rear because the habitat was really lacking. It was just all kind of one stagnant, void of vegetation type pool area. And so the first step in the project, after we did some initial look at the topography out there relative to the elevation of the stream bed at the start of our project up here and the lake elevations that were expected, realized, gosh, this thing is just too high. It had some fill placed on it historically, and really this would have been the better property if we could have purchased it. You can almost see a meander scar down there. So looking at that information, we realized we're going to have to lower this whole thing by 2 or 3 feet. So one design component was just mass excavation. That was probably the most expensive part of the project, was just lowering the whole surface so that we could run a stream channel through there and have it actually overbank and have a hydrologically connected floodplain surface. And this lowering is also going to be helpful for maintaining some gradient into Utah Lake. One of the problems on Provo River right now, they spawn, the fish spawn successfully every year, but then as the larvae drift down, it also is in a dredge straightened channel right now, and the fish either get stranded and starve because there's not a good food source, the water's kind of cold, it's not very productive, or they get eaten by carp and other predators, white bass, etc. They're like, sweet, there's no place to hide. And so that was the other thing we wanted to make sure didn't happen on Hobble Creek, was we needed that transition to be effective. So what we kind of did with lowering the surface was bring the lake up to the river, rather than having to bring the river all the way to the lake. And so kind of created this new bay of kind of a new scallop of Provo Bay along Utah Lake. And so then we had to design a new stream channel. We kind of returned the creek to a more natural, sinuous channel form with some diversity in the stream bed profile, some riffle and pool areas. Again, we wanted it to flood. We wanted overbank flooding to happen so that those floodplain ponds could be connected to the river channel, serve as high quality productive habitat areas for the young fish, and also serve as functional wetlands for UTA's needs. And we wanted the stream to be able to move around. We wanted that overbank system to happen. We had to maintain levees on either side of this property, unfortunately, to protect these adjacent properties. It's good that we're protecting them. It's just unfortunate we couldn't have a bigger delta, because this is definitely a little bit confined relative to what it would have been naturally. This is just a graph. This is one of the profile outputs of a model that we developed for this project while doing the design. It's a HEC RAS model, which is a one-dimensional hydraulics model that you can use. You insert topographic information, cross sections, and profile slope information, and combine that with some flows, and it'll model how high the water elevation is at a given discharge. And so this is the profile output. This is kind of the I-15 culvert. And in looking at this, as I mentioned, we had to look carefully at the expected lake levels. And during the spring spawning period, the lake level is usually way up to here. And so it creates this backwater effect that extended almost all the way up to the culvert elevation. So we really had a flat system, but we still needed to kind of get some velocity to push those young fish out. So that went into kind of designing this lip at the start of the project. And this was just an illustration of kind of some of the background and data and modeling that goes into design. The last component of the project are these floodplain wetland areas that have different levels of connection to the creek, some various depths. We wanted to have some diversity in the expected types of vegetation that would come about. And overall, the project was able to create about 14 acres of new wetlands. And this is just some shots of all the construction and earthwork. And this is the project, I think, the year right after construction. It was finished in November or December. This is the next year. And then this is just this summer. So you can see the vegetation has come in. So that's the restored delta area on Hobble Creek. Wanted to just touch on, I mentioned a few things, but what science went into this project. We had to do hydrologic analyses to figure out what the flow regime was on the creek so that we designed the right size stream to accommodate those flows to overbank when we wanted it to. We had to look at the lake levels that are monitored down at the Jordan Narrows outlet. We had to put some monitoring devices out there because the lake levels actually are a little bit higher. They get perched in Provo Bay. So a lot of kind of research and analysis on hydrology. We had to collect a lot of topographic data. We looked at historic aerial photos to try to get some better information on maybe what size and shape of meanders the creek would have had. Looked at some regional geomorphic relationships. Not a lot of great historic information because it's been channelized for so long, so had to kind of look a little bit broader to get some reference stream channels to design off of. I mentioned the HEC-RAS model that we developed. We had to do some groundwater monitoring. That's definitely a question that comes up, especially if you're trying to create wetlands. You want to make sure they're going to have a water source and make sure we dig them deep enough. And it's also an issue, how is our project maybe going to affect adjacent properties? And so that's something that came up in some of the public input that we got during the environmental assessment process. You also want to know before you try to put a river through something, what kind of soil is it? Is it super gravelly? Are we going to just like lose the flow underground if you're running it through a real coarse substrate? Or is it more clay and so forth? And then the various resource impact analyses kind of went into the project as well. Does anybody have questions about Hobble Creek? Yeah.
So what kind of sediments end up in the surface of the creek bed now?
The creek bed.
Size?
You know, it's mostly sand and some silt. There are some clay lenses that are fairly resistant, and so they've almost created some riffle areas down there. For this project, other projects we've done, we've actually like imported substrate if we're cutting a new channel through an old field or something. But this, the gradient was so flat that it naturally wouldn't have been a very coarse bedded stream. And so it didn't really need that. We did put in a few, we called them cobble V trenches that were sort of artificial, but they were there to hold grade. And then also the recovery program wanted us to at least try to create some spawning habitat down there as well. It naturally would have been more of a rearing area, the sort of interface with the lake, and they would have gone farther upstream to spawn. So we did place some cobble materials just specifically as sort of some spawning areas. And that's held up better than I expected. I thought it might just silt in, but those have been, we kind of built those as slightly steeper areas, and they've held up pretty well.
When you did the excavation, was it pretty much similar sorts of sediments that you were seeing in there?
Yeah, it was actually fairly consistent. There were a few lenses of slightly coarser sand that I think got dumped there when the river busted out in the 80s. It just dropped a whole load of sand. But as we got deeper down, it was more in those clay and silt lenses that are probably related to the lake, having been up there and dumped stuff up, you know.
Where did you take the stuff that you excavated?
That's a good question. Some of it, I don't totally know. The contractor, I think, used it on some projects elsewhere, not too far away. That was kind of an issue though that came up, that the June Sucker program was leery of the properties right next door, wanted to do some fill, and there's like a new storage shed unit right next to this property now. It did not get used there. It was kind of one of the requirements that we placed on there, just as they didn't want to be associated with, you know, and getting through our wetland permitting process. We didn't want to just be like, oh, well, we're just going to fill this other one over here with this material. But I can't promise that it didn't happen completely. I'm not actually sure where it all went. Anything else? Well, I don't have a whole lot more time, so I might skip through these next stream channel project examples or bust through them real quick. I'll mention this one because it's kind of an interesting project where we get to actually do geomorphology. Not all our projects end up really doing much geomorphology. This is a project, I'm actually going to be out for a meeting out there in a couple weeks, so we're still just finishing this up. Call this the Yampa River Intake Geomorphic Assessment Project. And this is a project we were hired by a power company that has a water intake pump right here on the Yampa River in Colorado, near Craig, Colorado. And they pull water out of the river for cooling ponds near their power plant. And the power plant went in, I think in the early 90s. And the river used to be in a different location when they initially put the intake in. And in the floods of the 80s, it started to erode into this floodplain quite a bit. And now the main channel flow, you can see, just heads right into that intake canal. And they've been having a heck of a time with some major sediment buildup right at their intake channel. They've had to dredge it repeatedly over the last decade or so. And they're kind of sick of doing that. And so they hired us to look at some other options to try to allow them to have less maintenance of their intake channel. And so we did some historic assessments, getting back to a 1968 aerial image, which the colored blue outline looks like. And you can see the intake channel used to be more at the downstream end of a bend, which is a more sensible place to have an intake. And the river has really been eroding and then developing this side channel over here. So it's been an interesting project. We did some surveying and high water assessments and developed a HEC-RAS model again and are looking at some different concepts. It's very conceptual at this point, but what are some options to maybe reroute the river so that they don't have the maintenance issue, Or maybe is there a way to reorient the intake canal that you don't have that sediment issue anymore? I'll touch on Red Butte Creek oil spill. We've been involved with some efforts there, partly because we had done the riparian assessments for Salt Lake City a couple years before the spill. This project is sort of interesting in that this entire bank after the oil spill was contaminated with oil and the stream bed itself through here. So this whole slug of material had to be removed and hauled away and disposed of properly. And we had to rebuild that whole bank and replace the substrate. And so that was kind of another design process to go through all of that. And we were able to kind of develop a opportunity to create more of a floodplain shelf rather than the sort of steepened banks that were all present before. And you can see in the after situation, we had some good vegetation recovery and so forth at that spill site. This is just a picture of the elaborate dewatering system that was in place while we were replacing the substrate, and some of the sketches that illustrated some of our concepts for the design. And I'm going to move on to a couple other projects, because I think we're supposed to wrap up very shortly here. I mentioned these Salt Lake riparian corridor studies. An interesting component of this is that I ended up doing a lot of public involvement type work, public workshops, trying to work with residents along the creek and interested parties to explain why we should care about these resources. I brought one of the reports, the management plan reports that we prepared for that. And I also have the Hobble Creek plan set here if anyone wants to look at that afterwards. I mentioned the Instream flow studies. I'm not going to get into that in detail, but that's an interesting project to work on from a scientific perspective, because you're really looking at how does stream flow, its magnitude, duration, and timing affect all these other resources. And so I'm headed down to Texas to work on the Guadalupe River on an in-stream flow study with our Texas staff next week, and I'm supposed to be trying to figure out how we can evaluate some of the sediment transport components, what's supporting the riffles, how is that affecting the macroinvertebrate communities that our biology staff are going to be sampling and evaluating. So these are also interesting projects from a scientific standpoint. And I'll just skip our exciting video. I'll mention a couple things just about what it's like to be an environmental consultant from a career perspective. So I kind of just made a little list of what have I done day to day over the last week. Let's see, last week I spent a morning at a construction management meeting for a golf course project up at the Canyons Resort, where we're having to reconstruct and redesign half a mile of stream channel. I went out on a site visit to a refinery property to evaluate whether I thought an area was potentially a wetland or not. And I mentioned next week I'll be doing this field work on the Guadalupe River in Texas. Those are all the more fun things that I get to do. I spend a lot of my time in the office at this point. I spent yesterday reviewing a proposal for some services that we might be able to provide Bureau of Reclamation on the Rio Grande again, estimating cost and scope for a stabilization project, working on that Yampa River report, and doing a lot of spreadsheets and GIS and phone calls. In terms of pros and cons, what my take on environmental consulting would be is that you're rarely bored. You have a lot of, you can tell I've worked on a lot of different projects. Things don't tend to get stagnant. You kind of get forced a little out of your comfort zone now and then. You get like, sure, I'm a wetland expert, and that's maybe not so much my thing, but you learn how to use the resources at your disposal, interact with some of your coworkers, and learn new things quite regularly. You get a lot of expertise and a lot of experience quickly. You get to do some traveling. Often the schedule can be pretty flexible. The pay is good. You're generally surrounded by a lot of skilled and efficient coworkers. The flip side, it's a very deadline-driven, can be pretty stressful type of workload. Many weekends and late nights, midnight sessions, trying to meet deadlines and proposal deadlines, that type of thing. And the other thing that can be a bit of a drag is you end up quite commonly working on more controversial type projects. You know, I think a lot of us get into this type of work because we're interested in protecting the environment, but you end up doing analyses of projects that you maybe think aren't really a good idea in the first place. And you have to sort of have a mentality of, well, this was going to happen whether I'm involved or not, and I think that my involvement can make it a better project at the end of the day than it would have been if I'm not involved. But sometimes that wears a little thin, but that's kind of how you justify it. The other thing that can be a bit unfortunate is you don't have a real long-term involvement with a project that you work on. You don't have long-term management responsibilities. You know, we did that work on Red Butte Creek, and like, oh, the vegetation all came in, it's looking really good. Next thing you know, somebody's building a new storm drain outlet channel right through what we just revegetated, or they're putting in a pathway and they didn't fix up the vegetation that they messed up. And you know what? It's not our property. We can't do anything about it, but it's frustrating in that sense. So I think those are some of the negatives about environmental consulting. Some of the skills I use the most, it's surprising how much writing you end up having to do. And you know, there's jobs you can do as a consultant that are mostly field technician type work. And those are great and they're fun. But if you kind of want to move up to the next level, you need to be able to do some research, pull together existing information, write it up coherently. You can really go far if you have a good writing skill that can balance your scientific experience. You use GIS a lot, GPS devices. I'm not an expert. You guys are probably way better than me at those at this point. I'm not up to speed on that technology. I rely on other people. But a lot of these tools are really evolving. So being up to speed on that is a great idea. And you work interdisciplinarily a lot. And so having some base understanding, taking some courses in some other areas is going to help you as well, long term. All right, sorry I didn't leave much time for questions, but.